Okay, guys, so we left off here with example number 8. I told you it was part of your video quiz, but I do want to make sure that everybody's got it. Hopefully, you were able to get it on your own so that you can get that homework done. If not, we're going to go over it so you can go back to day 5 of that first week and finish the video quiz and get on to the homework. Everything's going to be kind of open-ended for due dates for now. I just need the classes to kind of settle in, and then we can start pushing due dates to make sure that we're getting our work done time. All right, so just looking at example 8 to start out with. Again, first thing we've got here are parentheses. So we're going to look to distribute. And I'm going to start doing less and less, writing less and less, just because once you've seen it a couple times, you know what's going on, or at least you should follow. And unless there's something weird going on, I'm going to kind of roll right through the problem. So we've got negative 3n plus 15 equals 3n minus 27. Okay. I'm going to push this 3n to the right side. So if you've kind of picked up on the pattern, you know I'm going to add 3n. So I'm going to have plus 3n. I know it's going to disappear over here. Happens every time, right? So I need to do a plus 3n over here. So I'm going to have 15 equals 6n minus 27. And you can see how I have performed just the one step. I'm just not representing it anymore in the work. Now, if you liked that whole chain of events and it was easy for you to follow, great. But again, you know, as you do enough of these, you don't need to represent adding or subtracting something. You know what's happening, so you just kind of do that on the other side. Now, again, for this, I know I'm going to add 27. I don't need to write it down here at the bottom. I can kind of mentally do that, or do it on the calculator and write the result. So 15 plus 27 is going to be 42 equals 6n. Okay. And then I know I'm dividing by 6 on both sides, so I get 7 equals n, or, right, n equals 7, as I would prefer. So there's your answer for number 8 on the video quiz. So I'm going to go ahead and do 4 more examples, and this is just because these are really extreme, and I want to make sure that we cover pretty much everything you might see, so you know how to handle it. I'm not going to go over every which way you can handle it, but I am going to cover those just so you have some sort of reference. Excuse me. All right. So, example 9. All right. And this one looks very intimidating to start. So 4/5 of 10m plus 30 equals negative 3m plus 3. All right. So we can't shy away from fractions, and honestly, changing this into a decimal where you would say, oh, well, that 4/5, that's just 0.8. You're really working harder than you have to, because a lot of this is mental math. And so if you can do that, little bit of multiplication and division in your head, which for the most part is pretty simple, you can skip the whole 0.8 and then putting it in a calculator and doing all that, because as I know, when 4/5 gets multiplied, it's 4/5 times 10. Now, if you're really good with fractions, you know what a 1/5 of 10 is, and you'll just take 4 of those. But you can go 4 times 10 is 40 divided by 5. Well, 40 divided by 5 is 8. Okay, so 8m. Same thing here. 4 times 30 divided by 5. Well, 4 times 30 is 120. Divide that by 5. I know 100 divided by 5 is 20. So 20 more, that's 24. All right. So 24 equals negative 3m minus 9. Watch your signs, right? That's a negative 3 times a positive 3. I'm going to add this 3 this way. So that's 11m plus 24 equals negative 9. I'm going to subtract that 24 from negative 9. Again, integer operations can be the bane of a lot of our existence, but make sure we're doing it correctly. And if you didn't do it correctly, this problem gets kind of ugly, right? So 24 and negative 9, that's something like 15. Well, 11 and 15 don't play well together. And so you would kind of know you're on the wrong track, maybe try again. But negative 33 or 33 and 11 play very well together. So I know my answer then is negative 3, right? Solution. So I forgot just to go back on that one, just so you can see, I am going to do that. Make it a habit, right? Make it a habit. I got out of practice this summer, and I'm going to have to get back into practice for you guys. All right, so example number 10. Okay, example number 10. All right, we've got 3 halves a minus 26 equals negative 5. Okay, a little different. We're not just distributing with a fraction. We've actually got it as a coefficient here on a, and we're going to have to deal with that when we get to it. For right now, it's just a simple two-step equation, so don't get so fixated on the fraction. Just go ahead and work the process and see what happens after. Okay, so I add the 26 to both sides, so that I know that's going to leave me with 3 halves a equals negative 5 plus 26. So I got plus 26, negative 5, that's a 21. Okay, so how do we deal with this? Well, it's just multiplication, right? 3 halves times a. So 3 halves times a, that means I should divide. And so if you remember from any time that you are dividing by a fraction, so say we had 8 times, and we'll say 3/4, and this was last year. So what was the rule for that? It was keep it, change it, and flip it, right? So we would, and again, this all separate, we would keep the 8, so 8 over 1, we would change that, and we would call that 4/3, okay? Oh, I'm sorry, this one should be division. I was like, what are we changing? The division sign to a multiplication sign, right? So what essentially mathematically are we doing? We're not keeping, changing it, flipping. We are multiplying by the reciprocal, okay? When you flip a fraction over like that, that's called a reciprocal, okay? Reciprocal. All right, and honestly, that's all we have to do here, is on both sides, okay, multiply by a reciprocal. So that's times 2/3 as well. So what happens over here is you essentially would get 6 over 6 because, 2 times 3 and 3 times 2. Well, 6 over 6 is just 1, so you get your 1a you need, right? And now we're back to this whole multiplying with fractions affair, and we say 21 times 2, which is 42, divided by 3, which is 6. Okay, so solution, right? So don't let these kind of hiccups get in your way. They're entirely doable. We have to kind of take our time and know what we're looking at. All right, example number 11. All right, so we have 4 equals n minus 10 all over negative 3. Okay, now this one's a little different. Okay, it is just a two-step problem. We've got subtraction and we've got division, and so everything up to here in a two-step, we would focus on that addition or subtraction. But when it's shaped like this, and you'll notice the division sign goes underneath everything, okay? It's the n and the negative 10 that are being divided by the negative 3. So we've got to undo that division first, okay? So when you see kind of a shape in this manner, we're going to take that denominator and go ahead and multiply it out, right? Because the numerator by itself is protected until we get rid of this denominator. So we've got negative 3 here, negative 3 here. I know those cancel out. So I'm going to be multiplying by negative 3 on this side as well. So we've got negative 3 times 4, that's negative 12, equals n minus 10, because the whole point was those two are going to cancel each other out. And I've kept things balanced, so I haven't changed anything. All right, so negative 12 equals n minus 10. I know I'm going to add 10. Negative 12 plus 10, right, is negative 2. All right, so solution. All right, guys, last one for you, and then we'll let you on to the homework. We'll talk about that a little bit as well, okay? And that is example number 12, and then I promise I'm done going over just examples of this equation, these types of equations. So we've got, okay, k to the second power divided by 1.2 minus 7 equals 23, okay? Now this one has all kinds of ugly written all over it, right? Not only do we have a exponent that we have to deal with, we also have division with a decimal, so that's no fun either, right? But we have to look past that, right? We have to trust in the process and go ahead and start working the problem and see how things might work out, okay? So this one I am going to kind of write my way through like I would, just so that we can see every little thing that's happening, all right? So I know to start out with, right, it's two-step, so I'm going to add the 7, add the 7. Okay, those cancel out. On this side, I'm left with k squared over 1.2. You could also say k to the second power, and I have 30. Okay, now this is division. Okay, we've got to work back to that variable and isolate just the variable by itself. So I've got division that's kind of holding that variable up, and so let's get rid of the 1.2. All right, so we're going to multiply both sides by 1.2, so getting rid of that, not so bad. Those cancel out. I get k to the second power, or k squared, equals 30 times 1.2. You can do that in the calculator or off to the side in your head, however you want to do it. Essentially, it's 3 times 12, which is 36. Okay. If you want to know why it's 3 times 12, we shared the 10 that the 30 has. It's 3 times 10 times 1.2. 1.2 times 10, right, because it's commutative. 3 times 10 times 1.2. This is just math fun facts, right? I can do that in any order. That's still 30, and that's still 1.2. And since it's multiplication, I can share that 10 with the 1.2 first, which just moves the decimal. So I have 3 times 12, right? So that's 3 times 12. And that's how I did it. Okay, and there's all kinds of those things mixed in with math. But back to the problem. So k squared, right, equals 36. So to get technical, right, that just means some number times itself gives me 36. And I know you all just said 6. But you have to remember, or you have to know, that when you take the square root of a number, you're actually just guessing. So to make this algebraic, to kind of show what we're doing, I'm going to go ahead and write that, right? I'm taking the square root of k squared. And you have to remember k, that's k times k. So the square root of k squared is just that singular letter k, right? That's what's coming out of that radical. Then we have the square root of 36 on this side, okay? So what is the square root of 36? And this is where you've got to understand, these are our thought bubbles for square roots, right? So square roots. Okay, so we could have the square root of 36, and we could say, well, that is 6 times 6, right? Which means the square root of 36 is equal to 6. And I would say you're absolutely correct. 6 times 6 is 36. But you can't overlook the other possibility, right? This is like an alternate universe. Or you could say the square root of 36 is, right, negative 6 times negative 6. Still same number times itself, right? Negative 6 times negative 6 is equal to positive 36. So in that case, the square root of 36 is negative 6. So which one do we use? And the truth is, there are going to be times where only one of them will work in the equation. And you have to go back to some quadratics for that, which come way later in the year, okay? But for now, we're just going to write positive or negative 6, right? And if you want to, you can write it out as k equals 6 or k equals negative 6 if you need it separated, okay? And that's just because we did introduce that square root, and we have to understand that square roots, because they are an even number of factors, you can have positives or negatives, all right? So we're going to leave you with that one, and I'll just say a little bit about your homework, okay? That homework is externally linked, which means it's coming from somewhere else. It's already pre-done and pre-built, and it's just a test run. So if you're having a lot of issues or problems or anything like that, it's very limited on what I can do with it, but I'd like to know. If it does work, right, it should let you go all the way through it and kind of grade you. I believe every question you have 2 opportunities. If you miss it on the second opportunity, it's wrong, and I think it'll show you the right answer. So go through it, see how it works for you, kind of go through and complete that, and we'll see if the grading on it works, okay? We'll see you guys on Tuesday.